Processing time of an activity is the time it takes on average from the moment a person starts doing the activity to the moment they finish it, if we assume that they do it in an uninterrupted manner. The same technique we have seen can also be used to calculate the processing time of the entire process if I know the processing time of each activity in the process. Let me take the working example, but now instead of assigning to every activity the cycle time of the activity, I will only assign the processing time. I will apply the same methodology as before. I will divide my process into single entry, single exit blocks, and I will apply the flow analysis equations to calculate now the processing time of each of these blocks using their corresponding equation. This will give me, for example, for the rework block, that it takes 2 hours divided by 0.8 to perform the first block. The second block takes the maximum of 0.5 and 3, which is 3 hours. The third block is a simple activity with 2 hours of processing time, so that is the processing time of that block. And the final one is an alternative path block, and I know I have to calculate the processing time of that block as a weighted average of the processing time of the alternative path in the block. If I add all these components, I get that the processing time of this process is 8.9 hours. We mentioned before that a measure of efficiency of a process is the cycle time efficiency, defined as the ratio between the processing time, which in this case is 8.9 hours, and the total cycle time, which in this case is 8.65 days, which I can convert into hours by multiplying 8.65 times 8 hours of work per day, for example. If I do this calculation, I find that the cycle time efficiency of this process is 12.9%. More generally, if I want to calculate the cycle time efficiency of a process using cycle time analysis, I will first determine what are the processing times of the activities and do one pass of flow analysis to calculate the processing time of the entire process. I then will figure out what are the cycle time of the activities, and I will do another path of flow analysis to calculate the cycle time of the entire process. Then I will divide the processing time of the process by the cycle time of the process. In some cases, it is more effective to measure the cycle time by looking, for example, at the logs of the process, or by interviewing people or asking customers or asking people performing the process how much time on average it takes between the moment an instance of the process arrives and an instance ends, without using flow analysis. In some cases, this is a more pragmatic approach. Then I can use flow analysis to calculate the processing time of the process, and then I can do the ratio of the two and determine what is my cycle time efficiency. And that gives me a good idea of what is the health of the process as far as time is concerned.